продолжать. Мы возвращаемся после перерыва. Кто к нам только присоединился, мы сегодня здесь про DevOps.
Who have just joined us, let me remind you that we are talking about DevOps. Our next speaker is Alexey Knyazhev.
Всем привет.
Hi, everyone. My name is Alexey Knyazhev, and today I am going to talk about how we brought down to zero the OpEx for accepting Kubernetes clusters for the databases. I work in DBaaS, and I moved from a product developer to a platform engineer, and now I'm developing the platform of DBaaS, and I spoke about that in the last event. And I'm interested in Kubernetes and beer. Let's first look at what DBaaS is, specifically at Avito. Then we'll talk about how we Kubernetes to work with the databases. Then let's look at how we accept clusters for DBaaS, and then how we automated the process. Let's start with DBaaS and what is DBaaS at Avito right now. First of all, DBaaS is the database as a service, which means complete automation of the life cycle with the databases from deployment to delete to archiving, and it means that there is no cognitive load on the product developers, so they don't work with databases. They just write one command in the terminal, they click on enter, and they have the full base. The deploy service is fully ready with all the configurations. And we use Kubernetes for DBaaS. Why Kubernetes? Because it has quite a lot of the ready-to-use automations, a lot of open source solutions that can be used as an inspiration. And as is, Kubernetes also makes servicing the hardware easier. And so what the product the engineer has on the computer, they have the same in the clusters, and so we can deploy the databases, and we won't think about the discrepancies. And you can have a look at the numbers, and definitely the data is not complete, but you can see that the number of created storages is increasing. The numbers are not here, but for Redis and PostgreSQL, it's more than 20,000 created.
Если не ошибаюсь, около 4000. И связано
services per year, and that's a lot more than, for example, you can see that at Avito we have more than 4,000 microservices, and those rise in the product branches, and it's quite a significant number and rising. Now we have 4,600 active storages of 4 technologies supported on the platform right now. We're planning 7 more, and we have 11 Kubernetes clusters. Our plans for the future are features like sizeless databases, such as OK, which we are introducing right now. And we also expect to do the service in databases where we are more about availability, and it is the result interscaler, and we have a lot of other features that I'm not going to cover right now. So let's have a look at how we use Kubernetes and how we launch the bases there. I am not going to talk in detail about how we work in multi-DC paradigm, because this will take too much time. So a small meme for you to relax a little bit, and let's move on. To begin with, we wanted to understand how to do the persistent storage of data, and for this, we were using the technology which is called CSI, Container Storage Interface, and we chose Topo LVM. It creates persistent volumes with the usage of LVM, Logical Volume Managers. It supports dynamic provisioning and volume expansion without downtime. This was extremely important because often the users ask us to increase the disk space for their databases, and Topo LVM does that seamlessly and without downtime. Besides, Topo LVM ensures the isolation of volumes on the level of block units, and it has the integration with the Kubernetes planner, so you cannot really share the pods to the nodes without enough capacity. And we also run against a problem. Sometimes we see that if one of the applications it takes too many resources, one of the replies of the databases, they start using too much CPU, then the other applications launched on this node start degrading. In Kubernetes, there are native ways to limit the CPU and the storage. So what you do when your neighbors are too noisy, you limit the shared resources. And we also have to work on the disk and network arrays. And so we developed our own instrument that is called a network car, and it works with the basis where we want this. It is based on the TC utilized. It works in the sidecar container mode. It exports all the necessary metrics to for the network, and it reads the configuration of a YAML. And we also developed the input-output adjuster. It is based on the C group V2. It works in the daemon set A. It responds to the creation of pods on the node and exports all the necessary metrics for the input-output, and it works top-notch. Then we ran against the issue of servicing the equipment. Before I said that Kubernetes makes it somewhat easier when we need to do something. We can train it, and then we can download it, upload it, etc. But we have the databases. We cannot just depopulate the database. We have a certain storage launched in 3 replics, and for some reasons 2 are available, and something happened to one of them. And we turn off one of those replicas, and the database falls apart. And DBaaS DBaaS, the scheduler helps us with that. So when we try to evict a pod, which works together with the API, then this DBaaS, the scheduler decides whether it is possible to depopulate, to migrate from a certain node, and it can be a no, and then we will not depopulate a certain node. And DBaaS, the scheduler, used
опять по каким-то причинам.
Kubernetes drain and eviction API, and we are going to have an Avito database meetup. Please scan the QR code. And so what happens when we accept a cluster? Let's see what our Kubernetes cluster consists of for database and how the acceptance happens. There are a lot of components there, and probably the most conceptually important is the database operator. They are important because they raise the bases based on our control plane. They create services, config maps, etc., everything that is necessary for the database, and they make sure that the deployment is useful. Then we have Yoba, then we have DBaaS descheduler and console agent, which we need for database discovery work and update information in the console agent, and that's how database discovery operates. Then we also have the Topo LVM and plugin CSI for all the external things. And what's important here is that we don't set up the clusters ourselves. We get them from one of the neighboring teams, and one of them provides Kubernetes as a service. We get those clusters and top LVM and the agent. The VM agent are external, the rest is in-house. Apart from that, when we get clusters, we need to make sure that there is integration with a general database so that they could talk to each other. And in the storage, we need to make sure that there is the capacity node, and the nodes should have the right tains so that we can delineate the pools and the hardware where we can launch those databases are different. There is hardware where we only launch Redis, and there are others allocated, and we use tains for that in pools. And the tains should be aligned with equipment configuration, because if we have some medicine node, it can respond that the database is not working correctly because of the wrong configuration. The nodes should be tuned incorrectly. Everything can be fine in terms of hardware, but there can be some fine tunings, like the rate, for example. Besides, it's important to have the right certificates for the
они чувствительны к расхождению часов, и может стать плохо. Немного про генерацию SAN-сертификатов. Стоит отметить, что
as to the validity of SAN certificates, our storages talk to each other by using TLS, and same is true for the services. Same is true for the SAN certificates. To generate secrets and certificates, we keep all of this in Alt, and we use our own plug-in. So whenever we need to do anything, we start the process of generating secrets and certificates. We use the domain names with the replica of the set. It's the same as the number of the shard, the name of the storage, and in the domain name there is a mention of the cluster. And if in the new cluster there is no domain name, if it is launched in this cluster, then other replicas certificates of this. Storage will not be able to talk to it. And what is the acceptance of the cluster? At the beginning, we made sure that the tools were there, that the capacities are there, and that top LVM is there. And then we entered zero tasks, and it could take up to 2 days. Then we install our own components, such as Yoba console, etc. And then we launch a huge script which pre-generates all the SEN certificates, and it takes about a day. And if everything works, then we can migrate the test storage to this cluster, and we start using it. And so where is the issue? As you can see from the slide, you don't really want to work with loads of Java manifestos. It takes a lot of work. You have to make a branch copy-paste manifestos, and it should be error-free. Otherwise, it can result in interesting debugs. You have to wait for a review, and we have a lot of components, and I have not named all of them, but you are probably already tired. Besides, we have a lot of requirements for the provided Kubernetes clusters, and so according to Murphy law, if anything can go wrong, it will. And from time to time, everything goes wrong. Some of the requirements are not met, and issues start. As to accepting the clusters, so right now we have 11 clusters, and we accept them quite often because there are changes in infrastructure and issues with scaling up, and at least 3 are in the pipeline during the year. We'll have more to come. And we also spend the whole main sprint on accepting the clusters. We also spend a lot of our energy whenever we need to debug. We make mistakes in copy-pasting manifestos, and when it's sort of works, then anything can go wrong. These are the feelings we have, and so the idea is it would be great to do some automation. Let's see what we are doing. To begin with, we decided to automate the checks of clusters and worker node, and we have Kubernetes, which is popular in the company. It enables launching pods with the scripts of checks, and used on the exit codes from these pods, you can have the check status. It's not very convenient for specific worker nodes, but this is not suitable for us, but it covered all of our tasks to check the overall clusters, for example, to make sure that cluster is part of the overall DNS. There is also a node detector, which can check nodes, but it's bad about checking in the runtime. So we have to work with a plugin and mount pods with the node problem detector, but still it covers some of our issues. We decided to use Kubernetes for the checks, and for the nodes, we wanted to find something else, so we decided to do it ourselves, where the grass will be greener, it will export all the necessary metrics, work fine, and customize easily in the runtime. So it is a node validator, a pretty simple one, and one of the most important requirements. Until the node is ready, we should not load storage on this node, but if it ready and it has a storage, then we cannot just make it unavailable for planning. So the first attempt was Yoba, and since it's important to have the disk input-output when we have a new worker node, the Yoba cuts it off, and then when we do that, after it is checked, the node becomes available for planning. It works well. We get the nodes and we see that either it is banned and then nothing will work there, or otherwise we see that the capacity of the disk and we can use it. We looked at that and put together a full-fledged tool that is a node validator, and this customizes in runtime. And this is the manifesto for the checkup. What we have here, apart from the namespace, we have the priority of checking. If it is a priority, here it is true. And if one of the things doesn't work, then the node is blocked for scheduling. It has a special taint. If it is not a priority, then it doesn't impact the scheduling. And we also have a certain interval, and there is also the JQ for checking the sample of the nodes sample, and we check if the node is alive. This is a metric, and we decided to use these metrics because for a higher level solution, there were enough metrics, and besides, it doesn't result in the higher workload for the cluster the way it used to be before. And the in-depth checks are launched by the team that provides us with Kubernetes. And here is how it works. For example, we have two nodes and we have a node validator. We create a new resource, node validation, then it launches from time to time the checks of the right nodes. So they would select the nodes to check, then they will get from Prometheus the metric, compare it to the benchmark that is in the node validation, and on this basis they create a custom resource, node validation result. It's very simple. It has the namespace and the name, the namespace, and success or fail status. And you also have the conditions, which are more or less a native approach. If all the checks are fine, then the taint is removed. If it fails, then there is a taint for the node. And this happens only at the acceptance at the launch. And when the node is already operating, we don't taint nodes. And this helps us to make sure that we don't fix what is working and we don't launch what is not. And here you can see a beautiful dashboard, and there is the cluster with issues and 10 nodes have network errors. Actually, it turns out there was an issue with monitoring. Now it is all fine. Now let's have a look at the second part of the automation. once we automated checking, we decided to go into automating the deploy. It was sad and disgusting, and we use Argo City for this. We write in the repository the manifestos. We create the project in Argo City, and then it works fine. And before that, we use customization. And when we need to do a new cluster, we would have a new customization, write parameters, etc. It turned out that Argo City has all of it to automate the deploy components, to deploy components in the multi-cluster environment. This is play set, and it has generators to create projects in Argo City so that we can find the clusters, and your base going to be deployed only in the clusters with a special marker. And it is true, in the generator you can also set up certain parameters if we want to vary some parameters, or there is the blueprint for projects, and this is the policy of synchronization, sources, etc. And a useful feature was also to have a simple option for using the template of a project. We have application Yoba with the application set, and as the result of processing the application set, and Argo City creates applications. We don't do anything for the new cluster. We make sure that the dashboard is green and it works beautifully for us. But there is one last issue. The certificate, yes, automatic deployment and automatic checks and dashboards, but the script of certificates which you have to work for, this hurts. We created tasks for adding clusters in the configuration. We decided to take it for ourselves. So we have a special tool in our login, and this is what you have in the console utilized. So we move this to the right, and we have a new cluster. So in the system, we have a user. They register the cluster in our main control plane, DBaaS. Then we see that there is a new cluster created, and then the service that is responsible for the integration response, and our plugin adds the configuration to the new cluster. And what about regeneration of the certificates? The replicas of the storages use the TLS. We use some certificates in the subject alternative names. So we have the possible domain names for our replica storages. If some cluster name is not there, we it means no service or cluster can talk to it well. And we used to regenerate the names, and now we do it in a different way. So again, we have a user who decides to change the distribution of replicas, and if it is a new storage which was created after we did this cluster, then in the configuration of the plugin it is there. And so the certificates will initially be valid, and so it is relevant for the storages. It means that we want to pull one replica from one cluster to the other, then we use this handle. We have the console utility for this, and that's what it looks like. We have reduced one storage in 3 clusters. If we want to change something, we delete the first cluster, we show a new cluster, and then the distribution changes. Then the DBaaS automatically sends the message that the distribution changed, and the regeneration is launched automatically. And it looks like it is all nice and good. But where is the issue? The thing that you see there on the screen is, in essence, the list of the ongoing set of replicas of the storage, which are in one and the same cluster. In the slide, you can see the process for moving the replicas. And we have one in progress, which is being deployed now, and others are pending. And one more is deletion pending. We will delete it after the migration. And what does it look like? We have MBR, and we move then we deploy it first, and then we use the configuration to cluster 3. Then we make changes in the second cluster, and we remove this. And this is similar to rolling update.
Проблема в чем? Что формально у нас возможна такая ситуация, когда до того, как сертификаты регенерируются, в общем-то, вследствие синхронных событий, у нас ролик апдейт пойдет дальше. То есть он пройдет через все реплики, удалится старая реплика, а к новой не сможет подключиться, потому что сертификат регенерируется.
Whereas we won't be able to join. How to avoid this? Well, this is what we decided to do. We have a scheme according to which the rolling update only goes to the next stage, where the operator reports to the control plane that the replica is finished replicating. Update, all the checks are good. This is how it works. The database operator periodically goes up to host checking. So now it goes into the file system and checks the certificate. If there is no certificate in the cluster, then the host check fails. If there is one, it's good.
И только после этого мы отвечаем,
and only after this, we think that rolling update is complete. By doing this, we protect ourselves from the situation when a replica rollover destroys our DWH. So what are the results? Well, first of all, the instruction of cluster acceptance was reduced from 18 points to 2. The time of acceptance was also reduced from 1/3 of sprint to almost 0. So we basically have just one command which we use and see whether everything works well. If not everything works well, we'll just send this error to the guys who gave us the Kubernetes. Well, we decreased the desire of the guy on shift to go to his psychiatrist, and we are now covering with automated tests with those areas which have not been covered before. By way of conclusion, I would say the following thing. Well, first of all, database in Kubernetes is not really that frightful. Kubernetes has a lot of primitives to work with stateful applications. Kubernetes is a top program for tens of thousands of database. Argo CD is one of the top ones. It has a lot of solutions. If something is not to your liking, it's okay. You can always do it yourself. You can write it. You can have resources for that. Please go ahead. Thank you very much. You see my contacts on the slide. You can scan it, and the next slide
Алексей, спасибо.
opportunity
Заглядывайте вопросы.
to
Слева, справа
evaluate my
микрофоны.
presentation.
Большой вопрос, приз.
Thank you, dear friends. Let's ask the questions now. The mic is going to start. Right? The best
Проходи.
question. Yeah, right. Go ahead.
Да, привет всем. Скажи,
Yes, hello
получается,
to
персистентное
everybody.
хранение на нодах Куба
So what about
реализовали,
persistent
правильно?
Да.
storage
Ну,
on
наверняка у Авито
Kubernetes
есть
nodes?
как бы
That's what
инфра,
you do,
которая
yes. Yes.
предоставляет там
But
кластерные
Avito must have
склады
infra,
на цефе или
which
там на чем-то подобном.
must
Смотрели в
provide
эту
you
сторону
cluster
и какие плюсы и минусы
DBaaS.
видели?
So looking for that production with the yes.
Ну,
What
как
they
раз
can
проблема
also.
в том, что у нас довольно узкий список
Well, the
таких
problem is
фичей.
that
То есть, по-моему, из
we
средств
have
персистентного
very
хранения в Кубе у нас
small
сейчас
list
доступен
of
только
such
топ LVM. Там сейчас идут эксперименты
persistent
по внедрению других технологий, но они
storage
как
in
раз таки вот
Kubernetes
сейчас в процессе. Их
with
проводят, по-моему, как раз
no
ребята, которые дают нам
experience.
вот, поэтому, да, там было еще какое-то сравнение решений, когда только вводили топ LVM, но на тот момент он дал наилучшую производительность и в целом удовлетворял нашим потребностям. Поэтому вот так. Но, возможно, в будущем что-то поменяется.
Спасибо.
Спасибо. Еще?
Добрый день, спасибо за доклад. А как вы емкость планируете своих нод, которые вы заказываете у тех ребят, которые дают вам кубер?
Ну, тут на самом деле сложно вот так вот быстро ответить. Можем этот вопрос подробнее обсудить в кулуарах. Но если вкратце, то у нас есть некое прогнозирование потребления ресурсов. То есть у нас есть система биллинга. И есть некоторые статистические данные, то есть об использовании ресурсов наших кластеров, нод и так далее. И на основе, в общем-то, этих данных мы осуществляем приблизительный прогноз того, грубо говоря, сколько там в ближайшем году нужно будет там железа с учетом какого-то, ну, естественного роста. И исходя из этого железо заказывается. То есть вкратце это примерно так происходит.
И следующий вопрос. Собственно, кубовые ноды — это bare metal или на виртуализации они у вас сделаны?
Вообще у нас есть и те, вот, но преимущественно это bare metal.
Угу. Спасибо.
Спасибо еще. И как будто бы больше вопросов нет. Алексей, еще раз спасибо большое. Выбери, пожалуйста, лучший вопрос. Первый или второй.
Это сложно. Так, первый вопрос был про... СХДшки. Ну, давайте его.
Подойди, пожалуйста, к
Okay, let's
книжечку.
award the person who asked us with a book. Thank you
Well,
very
thank you
much.
once again
Thank
for
you.
the
14.
And the next
for the presentation.
slot
The next
is
slot is at
2 p.m.
14 hours.
Please
Please
join
come.
us.